Hello everyone, my name is Sivasai Nadella, and today I'll be presenting an agentic framework for continuous revenue governance across CRM, CPQ, and CLM systems. This work focuses on practical but unexplored problem, that is how to maintain revenue integrity and compliance when enterprise revenue processes spans multiple disconnected platforms. Rather than relying on static integrations, this research explores a coordinated multi-agent AI architecture for real-time lifecycle governance. I'll briefly walk through the problem context, related work, methodology, results, discussion, and future directions. Modern enterprises manage revenue process across multiple systems such as CRM, CPQ, and CLM. However, these platforms often operate independently, leading to data inconsistencies, approval delays, and revenue leakage. To address this challenge, this research proposes a multi-agentic AI framework that coordinates commercial, pricing, and legal decisions across entire revenue lifecycle. The framework was evaluated using 469 simulated B2B deal scenarios. Results show significant improvements in cycle time, revenue protection, and compliance compared to traditional rule-based integrations. Overall, the approach demonstrates how distributed AI agents can provide scalable governance for modern enterprise revenue systems. Enterprise revenue process typically spans CRM, CPQ, and CLM systems, which often operate in silos. This fragmentation can cause loss of context between systems, leading to revenue leakage, approval delays, and compliance risk. Traditional rule-based integrations mainly move data but cannot interpret complex deal conditions or revenue policies. To address this, we propose multi-agent AI framework where specialized agents coordinate commercial, pricing, and legal decisions through an event-driven architecture, helping improve compliance and accelerate quote-to-cash process. Enterprise revenue management systems have evolved alongside broader enterprise software architectures. Initially, organizations relied on monolithic ERP systems. Over the time, these evolved into a specialized platforms such as CRM for customer management, CPQ for pricing and configuration, and CLM for contract lifecycle management. Recently, research has introduced artificial intelligence into these platforms. In CRM, AI is commonly used for predictive analytics and customer insights. CPQ systems apply AI for pricing optimization, while CLM platforms use natural language processing for contact analysis. However, most of these existing studies focus on optimizing individual systems rather than coordinating decisions across the entire revenue lifecycle. This highlights a key research gap: the lack of integrated governance across CRM, CPQ, and CLM platforms. Multi-agent systems offer a promising direction because they enable distributed decision making and coordination among specialized agents operating across the enterprise systems. This research uses design and simulation methodology to evaluate distributed multi-agent systems for revenue lifecycle governance. The simulated environment represents a typical enterprise ecosystem consisting of CRM, CPQ, and CLM systems. Three primary agents coordinate decision making across the lifecycle: the commercial agent, the pricing agent, and the legal agent. Each agent focuses on specific domains such as deal structure, pricing policies, and contract compliance. Supporting agents manage data collection, analysis, and policy validation. The data agent gathers financial information, the AI analyst performs anomaly detection, predictive analysis, and policy agent verifies compliance with organizational and regulatory rules. Finally, the report generator produces governance insights for finance users. All agent interactions are logged to provide transparency, auditability, and traceability. This architecture enables continuous monitoring and coordinated decision making across the revenue lifecycle. To evaluate the proposed framework, we generated 469 simulated B2B deal scenarios based on de-identified real-world enterprise revenue statistics. These scenarios include variations in discount structure, contract classes, approval thresholds, and exception conditions. Each scenario was categorized based on governance outcomes such as clean approval, policy exceptions, legal exceptions, or escalation cases. The goal of this experiment was to compare performance of multi-agent governance framework against traditional rule-based integrations. The agents collaborate across commercial, pricing, and legal domains to coordinate revenue lifecycle decisions. Images show processing time with deal complexity and performance over the time. The results demonstrate significant improvements compared to the manual baseline process. Cycle time was reduced by approximately 85%, while revenue leakage dropped from 12.4% to 1.8%. Compliance scores improved substantially, and data errors was reduced more than 90%. One key observation is that the multi-agent architecture resolved over 98% of conflicts autonomously, requiring human escalations in only small fraction of cases. Additionally, the system scaled efficiently as the deal complexity increased, while manual process showing significant increase in processing time with complexity, the agent-based system maintained stable performance due to distributed coordination. These results highlight an important shift in how governance can operate within enterprise systems. Traditionally, governance mechanisms are viewed as slowing down deal execution. However, our results show when governance logic is embedded within an autonomous agent, compliance becomes a guardrail rather than the bottleneck. Most conflicts between sales, pricing, and legal teams are actually computational checks rather than strategic disagreements. Agents are well suited for these tasks because they can validate policies and constraints in real time. This suggests that future enterprise platforms should not only store the data but actively participate in business process through an intelligent coordination. However, the framework still depends heavily on availability of a high quality data structured data. In complex or ambiguous negotiation scenarios, human expertise remains essential, reinforcing the role of AI as a decision supporting system rather than replacing the human judgment. In conclusion, this research demonstrates the feasibility and effectiveness of multi-agent AI framework for end-to-end revenue lifecycle governance across CRM, CPQ, and CLM systems. Through the simulation of 469 complex deal scenarios, the study shows that specialized agents represents commercial, pricing, and legal roles can effectively coordinate governance decisions across the enterprise systems. The results indicate significant improvements, including approximately 85% of reduction in cycle time, reduced leakage, revenue leakage, and improved contract compliance. These findings suggest that the future of revenue operations may move beyond static integrations towards dynamic agent-based orchestration across the entire revenue lifecycle. For future work, the intelligence of these agents can be enhanced using large language models to enable semantic reasoning and negotiation over complex contract classes. Additionally, validating this framework on real-world enterprise datasets will be an important next step. This slide lists the key academic and industry sources we referenced throughout our research. Thank you. Happy to answer your questions. Appreciate your time and attention. Please feel free to contact me through email if you have any thoughts or collaboration in mind. Thank you.